All right, good afternoon, everyone. Our group is tasked with doing the topic hyperbola, and the name of my group members are Cynthia Sommer, which is myself, Javel Tom, and Julian AD.
Before you proceed, could you make use of the
Yeah,
whole
uh,
screen?
yeah, that is what I'm trying to go
Yeah,
and do
try
now.
to
I
so
forgot.
we can see rather than all this the toolbar and the taskbar and all the bars all over.
Okay, so outline here we have definition of conic section. How is a hyperbola formed as a conic section? Definition of hyperbola. Importance of hyperbola in real life, equations of hyperbola, eccentricity of hyperbola, translation of axes, examples of hyperbola, and if you have any queries, we'll do that at the end of our presentation. So the first question here, what is a conic section? Okay, so it says that a conic section is basically a curved form when a plane cuts through a double cone, which means two cones touching the tip to tip. So as you can see here, we have on my slides, we have the conic sections are circle, ellipse, parabola, hyperbola. So at the side here, we have a video showing the circle, the ellipse, the parabola, and the hyperbola. So when it cuts the cone at different parts, the way how it cuts the cone at different parts, that is how we have the different shapes being formed here. So if you cut this circle cone in a straight across, we'll have a circle being formed. And for the ellipse, if you cut the cone at a slant way, like this, as is showing here, you have an ellipse being formed. And parabola, if you cut the cone alongside, we will have a parabola being formed. But that was just, I was just going through that, seeing that we did those presentations quite some time now. But our main focus is hyperbola. So the hyperbola, mm, which is here, if you cut through both of the cones, you get a hyperbola. It's not only one cone that needs to be cut. If one cone is being cut, and that means an ellipse or a parabola is being formed. But when this glass here cuts both of the cones together, we will have a hyperbola being formed there, and we have the U shapes. U shapes it will be cut into. So the way how we cut the shapes, that is how we will get our that is how we will get our shape being formed. So that is very important how we cut the cone. So the next question is, how is a hyperbola formed as a conic section? Okay, so I have a video here. So as you can see here, before I start playing this video, we have the axis of cone. This is this green line here. Then I have this red line, which is basically like a glass cutting through these lines. So with this part here, this part basically will be our top cone, or we say the upper nape, and then the bottom part here we have the lower nape, or we say the bottom cone. So the double cone is formed by the two cones placed point to point along the same axis. So as you can see here, we have, well, this is one cone. This is this is one cone being formed here. Then we have another cone from here to here being formed. All right, so the video is moving. The video doesn't have any song. I'll be explaining it as we go along. So the red line is basically the glass that is cutting through the cone. So as you can see, as the red line is passing through, here we see that the cones would have cut across. And this is how the hyperbola is being formed. Because the red line here would have cut the cone and then the hyperbola is being formed here, which is basically the two U shapes that you can see here. The one in the purple line and the one with the brown line shown here. This is our hyperbola. So the cutting plane intersects both the upper and lower napes of the cone. So at the intersection, they forms two separate curves, and these open curves, they are called a hyperbola. Also, we have a diagram here too, showing showing the double cones. And when the glass is passing through it here now, and it slices through it, we have the hyperbola that is being cut off from here, being formed. Okay, so this is our hyperbola, and this is our hyperbola that we have when the glass cut is through the double cone. Then we have definition of a hyperbola. It says that a hyperbola is a set of all points in a plane whose distances from two fixed points in the plane have a constant difference. So we have the foci 1, we have foci 2, and we know the distance between them is constant. And this is a very important thing that we would like to touch on, the importances of hyperbola in real life. A lot of time we do a topic, but we don't know the importance of it. We do it just because we have to do it. So I like to touch on the importances of it. So the importances of hyperbola in real life. The first importances that we have here is the use of GPS. GPS and navigation. So hyperbolas are used in GPS and navigation. It helps us to find our exact location by comparing the signals from different satellites. So in case we cannot find our phone somewhere, we can simply use the GPS. Or sorry, to go to certain places, we use our GPS to find it. Okay, and the next reason why we can use the hyperbola in real life is that they help to locate mobile phones and signals. So the phone companies usually use the hyperbolas to locate where a call or signal is coming from. Another importance we have here is hyperbolas describe paths of objects in space. So some comets and spacecraft they move in hyperbolic paths when they travel fast and they escape gravity. That is why we can use a hyperbola to track them. Then we have the fourth one here. They are used in engineering and building designs. So the hyperbola shapes are used in bridges and towers, or we can say the cooling towers, because they are strong and they are very stable. And this one is a very important point here. Hyperbolas prepare us for higher mathematics. So as we ourselves can see the importance of it right now because we have to use hyperbola and do it in trigonometry so that we can able to complete our degree. So also another thing concerning this one here, it helps us understand more advanced maths using science or engineering and also technology. Okay, the parts of the hyperbola. We have a video here as well. So before I start the video, it says that the hyperbola is a conic section formed when a plane cuts both naps of a double cone. So as you can see here, we have our double cone here. This is one cone, and this is another cone being formed here. So the hyperbola has a distinct curve shape. So this is our first curve shape, and this is our next curve shape. So the center of the hyperbola, we have our center which is here, and the center is 0, 0. So the center is the midpoint between the two branches, which is, we know the center is usually the middle. That cannot change. So all important measurements, they are usually taken from the center. Okay, the vertices now, they are the closest points on the hyperbola to the center. So we have our center here. So from the center to this point here is our vortex. And from the center here to this point here, we have our next vortex. And usually the distance between from the center to the vortex is the same on the left as well as the same on the right. Okay, the foci of the hyperbola. The foci lie farther from the center than the vertices. So we know that the vertices usually be here, where the hyperbola intersects the x-axis, which is here. But the foci is just a little bit away from the vertices, which is exactly here. So we have one focus here and one focus here. So the greater the distance between the foci, the wider the branches will be. Okay, we're looking at the asymptotes now. So basically the asymptotes, they are the straight diagonal lines that we are seeing here. So as you see this red line that is coming from this direction here, this is one asymptote. And the green line here is also another asymptote. Sorry about that. Mm. Good. So we have our red line. This is one asymptote coming here. And the green line is the next asymptote. And we need to realize something. No matter how close we may see the hyperbola is to the asymptote, we should always know that they never touch. No matter how close they look like they are, they will never touch. Okay, the transverse axis now. The transverse axis passes through the center and the vertices. So as you see here on our x-axis, we have our transverse axis passing through, which is this green line that is showing here. The next important part we have here is a conjugate axis. The conjugate axis is perpendicular to the transverse axis. So this, in this case here, the conjugate axis is on our y-axis. Okay, the summary of all the parts here now. So the main parts are the center. We know the center is usually here at the middle. And the vortices, we have our vortices here and usually it's here. And the foci does usually be a little bit away from the vortices. Then the asymptotes, as I would have shown you earlier, it's the diagonal lines. The transverse axis is the line that is on the x-axis. And the conjugate axis is the line from on the y-axis. So the transverse axis is basically, and the conjugate axis, we can able to determine them based on how the hyperbola is formed. So if the hyperbola opens left and right, our transverse axis will lie on the x-axis. If our conjugate axis, for the horizontal hyperbola, it opens left and right. So the transverse axis will be on the x-axis and the conjugate axis will be on the y-axis. But this, take for example, if you have a vertical axis, that will open from up and down. And the transverse axis will be on the y-axis and the conjugate axis will be on the x-axis. Equation of a hyperbola. Okay, so the general form for the equation of a hyperbola centered at the origin, 0, 0 is. So we're looking at the equation of a hyperbola. This is the horizontal transverse axis. So when the transverse axis lies along the x-axis, the equation is x squared over a squared minus y squared over b squared equal 1. But the thing is that we might wonder, how did we come up with this equation? And we come up with this equation if you just look at the center here. The center here we have 0, 0. So the center of the hyperbola is 0, 0. That tells us that the equation will have the x squared and y squared only. And we wouldn't have anything like the x minus the h. As long as the center is 0, 0, we'll not use that formula as yet. So the direction of the hyperbola now will tell, as long as the curve is open from left to right here, that tells us that that means that our transverse axis is on the horizontal axis, which is our x-axis here. So this is our transverse axis here. So this also tells us that the x term must be positive. As long as we're looking at the horizontal transverse axis, our formula will start with x squared. All right, let us have a look at the vortices now. Yeah, the vortices, which is here, we have minus a 0 and we have a 0. So this tells us the distance from the center to each vertex is a. So from here to here is a. So if we divide x squared by a squared, that is the first part of our formula here. X squared divided by a squared. That is how we come up with our first part of the formula. And the conjugate axis now will help us to find our next part of the formula, which is this part here, 0b, and we have 0, negative b. So this gives a vertical spread of the hyperbola. The vertical spread of the hyperbola here. So since it's open left to right, the x square is positive, but the y square is negative. Another thing we know for hyperbola, one of the term needs to be a positive, which is the x square, and the next term needs to be a negative, which is our y square. So that is how we end up with our equation for hyperbola here. Okay, so equation of a hyperbola. The general form for the equation of a hyperbola centered at the origin 0, 0 is. So we're looking at equation of a hyperbola, but this is the vertical transverse axis. So when the transverse axis lies along the y-axis, the equation is y squared over a squared minus x squared over b squared equal 1. So in this case here, again, we might want to know how we came up with the formula. So what we do again, you can look at the center here. The center is usually 0, 0. And because our center is 0, 0 here now, the equation will have x squared and y squared only in the formula. And if you look at the opening here now, our opening here now tells us that it's open upwards and it's downwards. So this tells us that our transverse axis is vertical along the y-axis here. And yeah, and this is why our y squared term is positive. All right, if we look at the vertices now, looking at, so from our diagram, our vertices is b0, and then we have b0. Sorry, this one's supposed to be negative b. All right, so in this case here, this shows how wide the hyperbola spreads left, sorry, how far it spreads left and right. So when we divide the x squared, sorry, when we put the x squared over b squared, that is how we have the next part of our formula here by using the conjugate axis. But the question you might want to know, why do we have the minus sign in our formula here? The reason why we have our minus sign here, as I told you earlier, that the hyperbola usually have one positive term and one negative term. right, so equation of a hyperbola. We're looking at the equation of a hyperbola when it's not at the center. So when a hyperbola is not centered at 0, 0, we include the center HK in the equation. So the horizontal transverse axis, it opens left and right. It's the same thing as the one with the center 0, 0, but the only difference that we do here is just we put the minus H and the minus K in there. So our center, we represent it with H and K. We no longer represent it with 0 and 0 because it is not at the center. And we use our vertices as H plus or minus A and comma K. Okay, equation of a hyperbola. When a hyperbola is not centered at 0, 0, we include the center HK in the equation. So for the vertical transverse axis, this usually opens up and down. And our formula that we have is y minus k all square over a square minus, and then we have k minus h all square over b square equal 1. And our center, we can, as I would have said earlier, that we cannot use 0, 0 because our center is not at 0, but it's farther away from 0, 0. So that is why we place it with h and k. And the vertices is h and comma k plus or minus a. So for this part here, my next part, I'll be talking about the eccentricity of hyperbola. Start Javel.
So the eccentricity of a hyperbola, it defines the curvature of the hyperbola. So here we have a formula and it says the distance from center to focus. So it is actually talking about, we have the center here and the focus is all the way here, right? So that is our C value. So from the center to the focus, or some people would say the foci. Next, the distance divided by the distance from center to vortex. So we have the center here and we go to the vortex, right? So the vortex there, and that is going to be our A value. So we can try an example. So here we have x squared divided by 36. X squared divided by 36 minus y squared divided by 9, subtract 1. So we have our A value and our B value. So to find your A value, we know that this is A. So 36, and you square root 36, and now it's going to give you 6. So that's your A value. To find for B, you simply square root 9, and that will give you 3. So we use the formula C square equal A square plus B square to find for C. So we just substitute our A square and our B square. So we know A square is 36 and B square is 39. When we add that, it's going to give us 45. So we still have C squared here. So to remove the square, we will have to square root 45. And when you square root 45, it's going to give you 3 root 5. So now that we know our C value, we can write that. And we also know our A value, which is 6. So we substitute that. So our eccentricity is going to equal to root 5 divided by 2. And remember, the eccentricity defines the curvature of the hyperbola, how it is curved. Next. Now we're going to look at the translation of axis. So the translation of a hyperbola, translation of axis. So we have the hyperbola centered at HK. So we have it in this form here. So when we have a negative y, in this case, if you look here, you'll see a negative y there. The transverse axis it's going to be the x-axis, right? So by using this diagram here, we can see our transverse axis. That is our transverse axis here. Well, in this case, this graph is a horizontal hyperbola. So that's why the reason why we have a x transverse axis. The transverse axis is on the x-axis. When you have, in this case, when the y is positive, the transverse axis, that would be on the y-axis. So I have an example here to explain explain more about the translation of the x-axis. So first, this equation that is given here is not in the standard form, so we will need to write it in its standard form. So what we can do, we can divide everything by 2, right? So if we divide 2 by 2, that will cancel out to give you 1 there, and this will also give you 1, right? So we'll have 1 there. So now we're left with this. We're left with this, which is x minus 1 all square divided by 1 subtract y plus 2 all square divided by 2 equal 1. So that is actually the standard form, and you can look here and you can do your comparison. It looks the same. Now let's find our center. If we look here, we will see x minus 1. So our x value is going to be the opposite of that, which is positive 1. If you look here, you will see y plus 2. So we're going to use opposite, right? The opposite of positive 2, that will give us negative 2. So our center now is at 1, negative 2. So we can now draw our line. We can now draw. So this is, we're going to cut through the x-axis. Sorry about my drawing. So, and then we're going to draw another line using our y value, which is negative 2, and that's going to pass through here, negative 2, because the y-axis. So we can see our center is here. That's our center, and we can call here y prime, and here we can say x prime. So it's basically like we create a new x and y axis, because it's a shift. It's not at the center anymore. Next, we're going to we're going to find our a value. What is our a value and what is our b value? So we know that a is 1. If you look there, you'll see a is 1. A is 1. So if we were to square root 1, it's going to give us plus or minus 1. And if we square root 2, it's going to give us plus or minus root 2. So what we're going to do, we're going to locate these points on the graph. So A, we're going to move, remember A is underneath X, right? A is underneath X. If you look here, you'll see A is underneath X. Alright, so it means that we're looking at the X value, so we're going to move one place to the left and one place to the right. So here we move in and there, so over here, so both places. All right, next we move do you mind going back to the next slide for me? Yes, thank you. So we locate our points, our points there, and now we're going to locate our point for B. So it is plus or minus root 2, and that is going to be approximately, so root 2, that's approximately 1.4. So 1 and 0.4 should be approximately here. So from the origin you move up, and from the origin you move down. So this is going to be the negative value for B. So we have negative 1.4. That's here. Now we can draw some broken lines to form a rectangle to connect the points. Now when you connect the points, you can now draw your asymptotes. So if you look here, you will see the purple line. You will see this purple line here, that line there, and you will see this orange line there. So those are our two asymptotes. Now this will be our positive asymptotes, the one that is over here. This is our positive asymptotes. Over here, this is our negative asymptotes. Now when you draw your asymptotes, you can now draw your hyperbola, and your hyperbola, it must touch the vertex, or rather we can say the rectangle. So you have your asymptotes, you have your hyperbola there, and over here you have your hyperbola. So now the hyperbola is, it's getting closer and closer to the asymptotes, but it will never touch. Um, so to actually find your C value, that would be from the center to the foci, the center to the foci, as mentioned earlier. So to find the foci, it's going to be c square equal a square plus b square, and we substitute. Well, we know that a is 1 and b we have root 2. So when you add those, sorry, a square is 1, and we have b square, which is 2. So we add those together, and that's going to give us 3. And when we square root that 3 now, it's going to give us plus or minus root 3. So if you move from the center all the way to the foci, that should give you root 3. Right, positive root 3 here. And if you move from the center to the other direction, it should give you a negative root 3. Now the transverse axis is equal to a, right? So whatever the value is a, you multiply by 2. In this case, our value for a is 1, so we multiply 2 times 1, which will give us 2. Right, and this is our transverse axis. So if you check the distance there, it's going to give you 2, and the conjugate axis is 2 times b. So we know that our b value is root 2. So 2 times root 2 is going to give you 2 root 2. So from the So you start from the point here and then you go up, and that's from the point and then you go up there, and it should give you your conjugate axis. Next slide. All right, so here we have an example of a hyperbola where it is at the center. The center is at 0, 0 rather. So the question says, or the exercise it says, sketch the hyperbola. Find the coordinates of the vertices and foci and find equations for the asymptotes. So I showed you guys earlier how to sketch the hyperbola. Well, first you need to locate your a value, and we know our a value is 16. Our a value is 16, so we just square root that and it's going to give us 4. We have 4 there, and also we square root this 4 and it will give us 2. So we have our a value and we have our b value. So our a value is 4, and remember when we square root when we square root 16, it's going to give us plus or minus 4. Same thing here, plus or minus 2. So we will have a positive 4, and then we will go up to positive 2 there. Then we have a positive 4, we go down to negative 2, so we have a point there. And then we have negative 4, then we have a positive 2, negative 4, and we have a negative 2. And you just connect the lines and you draw your rectangle. When you draw your rectangle, you draw your asymptotes, both asymptotes. So you draw your asymptotes. It must pass through the center, and then you can draw your hyperbola or your hyperbola. So we can see our vortex here. This vortex here would be, this would be 4, 4, 0. I don't know why my pen isn't writing. Yeah, so that is going to be 4, positive 4, comma 0, and then we'll have negative 4, comma 0. So those are our vortices there. Another thing, we can find the foci. Now the foci formula, you can say h plus or minus, then we have c, comma k. So we know that our h is 0, the origin is at 0, 0, so our h is 0, so plus minus our c value, well, we found that our c value is going to be 2 root 5, and k, that is our, that will be 0 as well. All right, so we know that our foci is going to be a positive 2 root 5 comma 0, and the next one is going to be 2 negative root 2 root 5 comma 0. So we can now plot this on the graph. So that should be approximately approximately 4.5. So 4.5 should be here, about there and over here. So we have, let's say, f1, and this is f. Oh my bad. And this would be, let's say, f2. F2 there. Um, yeah, can you move to the next slide for me? Yeah, so when finding for C is the same formula we use, the same formula, which is C square equal A square plus B square, and that's how we end up with with the 2 root 5 that was mentioned before. Now to find the equation of the asymptotes, so the equation is going to be y minus k equal plus or minus b divided plus or minus b divided by a, and then we have times x minus h. So we're going to substitute our values that we have. So we have equation r, y equal plus or minus. Now we know our b value. We have our b value, which is 2, because if you square root that is 2, and our a value, we square root that, it's going to give us 4. So this can be reduced, and it will give us this plus or minus y equal plus or minus half x. So we use this formula when our hyperbola is a horizontal hyperbola. When it is a vertical hyperbola, we will have a switch there, and you will see as we move on. Next. Yes, so now in this case we have y in front, so we have a positive y there. So we have y squared divided by 9 subtract x squared divided by 25 equal 1. So we find our a value. So to find your a value, you will need to square root that. It will give you 3. Square root of 9 is 3, and the square root of 25 is 5. So we have our a and b. So we can actually use that to plot. So we know that y, our a value is underneath the y, so that would be on the y-axis. So it means from the center, you're going up. From here, you're going up to 3. So this is 3. So you stop there, and remember this would be a plus or minus as well. Plus or minus 3. And from the center, you move down. So it will be negative 3. So right here. And your b value is 5, so you move across at 5, and you can draw your rectangle. But in this case, let's locate our vertex or vertices. Our vertices is at 0, 3. So this is at 0, 3, and here we have 0, negative 3. That's our vertex, and we have our asymptotes, as you see there. So to find the foci, we'll need to use the same formula, which is a square equal, sorry, which is c square equal a square plus b square, and we substitute for a plus b. So we have 3 square plus 5 squares, and that will work out to be 34, and we're going to find the root of that. So the foci are So we have 0 root 34, 0 root 0 negative root 34. So now we're going to find the asymptotes. Or before we find our asymptotes, we can go and locate the foci. So this is the positive foci here, and you can simply punch in your calculator root 34 and you will get an approximate value, which is 5.8. So that would be approximately right here at that point, and our negative value is going to be negative 5.8 right there. That's our asymptotes. Now find the equation of the this is our foci and this is our foci. So we're going to find the equation of the asymptotes. So we have y equal, and this time we'll have a, right? So we'll have y equal plus or minus a divided by b. So this is the opposite of what we did before. So we switch the values. So we write our a value. So our a value, we can see that it's 3 there, and our b value is 5. So it's 3 divided by 5x. Y equal 3 divided by 5x, and our negative value is y equal negative 3 divided by 5x. So this is y equal negative 3 divided by 5x. Sorry, not negative. This side is positive. So we'll have y equal positive 3 divided by 5x. And over here, this is our negative asymptote, so y equal negative 3 divided by 5x. Next slide. Now, with this equation that we have, it is not in the standard form, so we will need to write it in the, we'll need to write this in the standard form. We need to write this equation in the standard form. So this is the standard form. So what we need to do is basically find the reciprocal. So it's going to be y squared divided by quarter, subtract x squared divided by quarter equal 1. So if we square root quarter, it's going to give us half. So we have a is equal to half, and we have b is also equal to half. So we found for our a and b value. So by looking at this, we can say our vortices is going to be 0, 0, positive half, and 0, negative half. So if you look here, you will see this is half there and this is half here. So those are our vortex on the graph. Now the distance from the center to the foci, we need to find that. We use the same formula, which is c squared equal a squared plus b squared, and we substitute. So we quarter plus a quarter, that will give us half, and if you root that, it's going to give you root 2 divided by 2. So that is our c value. So you can actually go right here and locate your foci there and your foci here. So that would be approximately, let's say, approximately 0.7. 0.7 there, and this one would be negative 0.7. So that is our foci. Now the equation of the asymptotes, we have y equal plus or minus a divided by bx. So we know our a value is half and our b value is half. So these will cancel out, which will just give us x. We'll have y is equal to plus or minus x. So here our asymptote is y equal, our asymptote is y equal plus or, yes, so the positive x, and here we'll have y is equal to negative x. Next slide. So here we have another equation where by looking at this hyperbola, we can see the center is not 0, 0, and also, yeah, we can see the center is not 0, 0. The center is here, so it's not 0, 0. Another thing that we can pick out is the hyperbola is horizontal. It is horizontal, meaning the x is in front and we have y here, a negative y. So we can point that out. So to actually find the center now for this hyperbola, we'll have to take this value, which is negative 2, and I will change to positive 2. Here we change to negative 4 and change to positive 4. So we have our center there. So if you locate here, it's at 2, and then we go up to 4. So the center is right there. Now let's try to find the vertices. So the vertices, that would be here and here. Now to find the exact value, we just use this here, which is h plus or minus a comma k. We know our h value, which is 2, so we substitute here 2, and we know our a value, which is 3, so we substitute that. We have the 3, so it's minus 3 comma 4, and we work this out. 2 subtract 3, and that will give us negative 1, 4. So the negative, so that would be over here. Alright, that's a negative vortex. So let's find the other vortex, which we have positive 2 plus 3. So we work that out, that will give us 5 comma 4, and that would be here. And if you check, you will see that it's accurate on the graph. Alright, so those are our points. To find your C value, you repeat the formula. So C is equal to root 13 when you work that out. And we can now plug that in. We can now take that and plug that into this formula there. So we have H, we know our H value, which is 2. And we have our 2 there. We'll have negative or minus root 13 comma 4, and over here we'll have 2 plus root 13. And when you punch that into your calculator, it should give you a value that is there and here. So that is our foci points, or 2 foci points. Now the equations for the asymptotes, where we have y minus k equal plus or minus b divided by a, open bracket, x minus h. So we substitute. We know our h is 4, so we can check. Sorry, we know our k. We know our k value is 4, and we can substitute. Our b value is 2 and our a value is 3, and h is 2, so we work that out. So this is actually our equation for the asymptotes. Next slide. So here we have another equation. It is not in the standard form, so we need to write it in the standard form. So first we will perform the perfect square. First what we do, we group. So we group the like terms, and then we're going to look at the b term. We find half of that. So we know, sorry, we factorize. So it's going to be 4 open bracket y squared plus 10y. So when you multiply this, it's going to give you back that 40. So now we're going to find half of 10, which is 5, and then we're going to square that. So we square this. We find half of 10, which is 5, and then we square it. It gives us 25 there, and we repeat the same thing over here. Alright, so we found um, half of 4 is 2, and then we square that, and it gives us the same thing. Now, if you add this here, you will need to do the same thing over here. So you need to add the 25 over here. So 4 times 25, that's going to give us 100. So we also we would have added this 4 here, so we need to do the same thing over here. So the reason why we subtract is because of this sign here. There's a minus sign there, so we need to remember that sign, and then we use the sign that is here. So it's going to be minus instead of subtract. And we work it out, and it will give us 4 open bracket y plus 5 all square, subtract x plus 2 all square equal to 36, and 36. Right? Divide everything by 36, and it gives us this. So now that we have it in the standard form, we go ahead and plot on the graph. And basically it's the same concept you follow to plot the graph. Now there is something I would like to point out about the domain and the range. Now the domain, so we have the domain and we have the range. Now we know that the domain is the x-axis and the range is the y-axis. So if we look at the curve, we can see the curve, it extends, and if we look at this curve, you'll see that it extends and it goes down. So it means the x values will increase. It will keep going on and on. So it means we'll have let's say a negative infinity, and then we'll also have a positive infinity because the graph will continue to extend. Now when it comes to the range, now the range is going to be your y, that's going to be your y values, or we will be speaking about the y-axis. That would be, if you look at the curve, it's down, this curve here, down, goes down, but in terms of going up, it stopped at the vortex here, right? So the vortex there, it is negative negative 8. Alright, so the vortex there is negative 8. So it goes down to infinity, but it stops directly here. Alright, so we will say that we'll have a negative infinity and then we know that it stops at negative 8. And we can say it is a union of, let's look at the other part of the hyperbola. You'll see that it does the same thing, but it starts from -2. Yes, so it starts at -2, -2, right? So we can say infinity, it goes down for infinity, but it stops right here. And there's a space here, so the graph doesn't continue here. Right? So we can say infinity, comma, so it has a positive infinity and -4. Next slide. So here we have some equations. Sorry, we have the vortex and we have the foci. So we are going to write those in the form of equations. So number one, we're given the vortices ±2, 0, and the foci ±3, ±3, 0. So we're given that. So now what we can do, we need to write it in this form, the standard form. But how do we know x comes first? How do we know we're going to use this equation rather than not having the y in front? So what we do, we can check and see that this value here is in the x place. So we know that this is x. So we know our a value should be underneath here, right? We don't have anything for y, so you already know we should use this formula. So what we do, we figure out our a value. So we know this part here, this should give us our a value, which is 2. And the foci, remember we would have calculated for c, so the foci, this is c. The ±3, this will give us c plus 3. So now we can write it, use back this formula, and we substitute for c. We know that it is 3, and we square that 3 equal, we know our a value, which is 2, so we square that 2, and we're finding for the b. So this will give us 9, this will work out to be 4, we write that back. So we have b squared equal 9 minus 4, and b squared equal to 5. So we now have our b squared. So we can now write back our formula, our equation, which is y squared divided by 4 subtract y squared divided by 5 equal 1. So you substitute there. Number 2, we have the vortices and we have the asymptotes here. So what we do, we already know that this is our a value. A value is 1, and the asymptotes now, the asymptotes of a horizontal hyperbola, we know that it's horizontal because it's in this form here, and we see that we have our x value there. So that is a horizontal hyperbola. So we substitute our, so we have y equal plus or minus 2x. So in this case, it's going to be in the form of b is going to be in this form, plus or minus b divided by ax. So if that gives us 2, we know that the value should be, it should be 2 divided by 1, and that's going to give us 2. So that's how we're going to put it 2. So our a value is 1, our b value is 2. and we take that and substitute. So we square 1 and we also square 2, and that gives us this equation here, which is x squared divided by 1 subtract y squared divided by 4 equal 1. Next slide. Now we are given one where we have the vortices and the asymptotes. But if you look here, you will see the vortice, the value for vortices. It's in the y place, so that's y. This is our y value. So y should be in front now. Alright? So we have the y squared divided by a squared subtract x squared divided by b squared equal 1. The vortices, so we know that our a value is 3, and our asymptotes, this is going to be y equal plus or minus a divided by bx. So if our value is 1, it means that a is equal to 3, and then we divide by b. So if we have 3 divided by 3, that should give us 1. So we know that our a value is 3 and our b value is 3. So 3 divided by 3, that gives us 1. So we take those and we substitute. So y squared divided by 3 squared subtract x squared divided by 3 squared equal 1. We square those, give you 9. So y squared divided by 9 subtract x squared divided by 9 equal 1. Next. Now, is there any questions you guys would like to ask? Is there anything you would like me to review? If not, we will move to the next slide. Next slide. And this has brought us to an end of our presentation. Thank you for listening.
That's it.
Yes, sir.